This is an AB calculus F F prime problem, and here it is. We have a graph, and the graph looks like a piecewise function. You have two pieces, this one up here above the x-axis and this one here that straddles the x-axis below. And it says the figure above shows the graph of the derivative of continuous function f for x is greater than or equal to 0, less than or equal to 4. And so if this is a derivative, graph of derivative, we can just label this function f prime or f prime of x. Okay, so there we have it labeled. That's the graph. And then it asks part A, for what value of x is f increasing? Well, this goes back to what we've been dealing with for quite some time in this class. If we have our f prime, f double prime, we know that our function is, we can put plus minus here, we can put draw up arrow, down arrow, and then finally the concavity, concave up, concave down. And down below the f prime, we just kind of take this plus or minus down here, increasing, decreasing, and not we're going to need it for this problem. We can put plus or minus finally down below here in the f double prime. And so for what values of x is f increasing? Well, this is a graph of f prime of x, and so here is our increasing on the f line, and we know that whenever f prime is greater than 0, our function is increasing. And we can put the justification in advance. Okay, it says justify your answer. I'll say because f prime of x is greater than 0. And so we put our justification already, and now for what values of x is f increasing? Well, we see that f prime is greater than 0, which is this requires, between, so we can say on the interval, and we'll put between 0 and 2, and also between 3 and 4, and then I'll just draw the arrow here to bridge the gap here. Okay? For what values of x does f have a relative minimum value? Justify your answer. Well, relative minimum, we'll put the justification in advance, because f prime of x changes from, okay, let's see, I have to get this straight. Relative minimum, you're changing from decreasing to increasing, which is going to be from negative to positive. So negative to positive. And where does that occur? Well, it looks like here at 3, because we're changing from f prime of x being negative to f prime of x being positive. So we can just say at x equals 3, because f prime of x changes from negative to positive. For what values of x does f have a relative maximum value? Justify your answer. Well, again, it's just the opposite of what was above, and this time justification is going to be because f prime of x changes from positive, right, positive to negative. And where do we see that? We see that right here, because you're positive, 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 then all of a sudden you're down to negative at 2. So we say at x equals 2, and again, the justification. So for these parts A, B, and C, we wrote the justification in advance. Okay, if f of 1 equals 1, use your answers to A, B, and C to sketch the graph of f for between 1 to 4. Okay, 1 to 4. Let's, I guess I'm going to do that below here. I think we have enough room. Okay, we have a graph here. We want to go between 1 and 4, so 1, 2, 3, 4. So there's 1, 2, 3, 4. And we also say if f of 1 equals 1. So here's f of x. So that's 1 here. We can just draw in here. There it is. Okay, f of 1 equals 1. Use your answers to A, B, and C to sketch the graph of f. So what happens, we are increasing at a slope of almost 2, and we're increasing because we're above the x-axis, but we're increasing at a decreasing rate. So we have a slight, what we would call down concavity. So we're going about 2 and all the way up to 2. So I'm going to draw a point here. And so we're increasing. This slope is 2 and gradually didn't decrease from about 2.5 to 2. So there's going to be a slight, I'm going to just sort of red, a slight curve like this. Okay, so there it is. And then it says we have a negative slope, and that's the slope of -1 at that point. And we have an up concavity because we're going up at this point. And we have a slope of 0 down here. So just to estimate where we would have to target at 3 would be maybe about here. Okay, and we are concave up, and we have a relative, now remember this is a relative maximum at x equals 2, which we have. And so now we have something like this, and a relative minimum at x equals 3, and we continue up like this. So that's going to be it. This shouldn't have been a very hard problem. Very simple, using our f prime, f double prime sheet here. Good luck. Learn from your mistakes. And as always, thanks for viewing.